I recently finished my master's for interaction design, and I'm excited to present you today the whole story of my master thesis in a summary and with all insights behind the scenes for the design process, for the development process, and the evaluation. Right. My topic is called Hand UIs with Multisensory Feedback in XR, and I'm exploring haptic feedback for virtual variables and mid-air interfaces. I created a prototype to investigate especially the scrolling interaction on your arm with haptic feedback. I created a workflow to enable new possibilities to design haptic feedback for compelling user experiences in XR. Hands are the most natural input device or modality. I see great potential in combining hands with AR and haptics. It's proven that tasks are performed more efficiently when visual, auditory, and haptic stimuli are combined. And during my first interactions with hands in VR, I realized how important it is to feel the sense of touch and how much potential gets lost without it. It's like a ghost without senses. So there's a big lack of haptic feedback for user-friendly hand interactions in XR. Technology is ready, but expensive and complicated, and mostly only accessible to develop for developers. So I was looking for a low-budget solution, and I found one. My approach allows to integrate haptic feedback for less than €150 if you have a headset with hand tracking support. The solution is simple. I use, as you see in the video, the audio output of a headset. I attach a Y cable to split the stereo signal. On the left side is haptics, on the right side audio. And when I press in VR, for example, a button, audio and haptics are played at the same time on separate channels. For the development process, I first experimented with Vuja. It's the big thing on my wrist that you see underneath the sock. I soldered my own Y cable, and in the second version, I used Velcro to have a proper wristband. And yeah, then I discovered Baselet. It's smaller and wireless, and yeah, that was my go-to haptic display. And on the software side, I experimented with Interhaptics, Lowfeld Studio, and Syntacts. And I chose Syntacts, and the main reasons are it's audio-based feedback, it's free and open source and ready to use, and it has a ready-to-use Unity plugin. That's how Syntacts looks like. It offers all possibilities to design haptics, and all these possibilities can also be processed directly in Unity with C#. And you can, for example, set there the frequency or duration for vibrations directly in the inspector, and that makes it pretty powerful. Here, a little example, you don't need to understand it, but at custom haptic design, at element 0, the X value, for example, is the frequency, and the Y value is the duration of the vibration. And this workflow opens many doors to explore new hand interaction patterns in a prototypical environment for XR. For the design process, it's crucial to think and create early on in 3D. First, I gathered inspirations in Notion, as you see here, and my sources for that have been Twitter, Dribbble, Pinterest, and LinkedIn. And yeah, then I created first ideas within a workshop, initially as 2D sketches, first with Miro. Here you see just an overview, don't need to understand the story behind it. And then I visualized the best ideas in Procreate to communicate them best in a team. And afterwards, I directly jumped into 3D and VR with Shapes XR. It was perfect for fast or for rapid prototyping and on a low fidelity level. Right, and after several discussions in a team, we decided for the ARM UI The advantages of this ARM UI are that I can use the proprioceptive sense, and this allows me to interact on the arm even out of sight. And the human haptic system provides maximum natural feedback. And as the arm is in a rest position, there is also a low arm fatigue, and this is especially a big topic in hand interactions for VR. The disadvantages are that 2 hands are required, so this excludes restricted situations or people with disabilities. The implementation of arm tracking is still complicated, and yeah, I didn't have a solution for now. So yeah, right, that are the advantages and disadvantages. After selecting an idea, I used Tvori for PC to explore the user flow in an animated prototype. This is, for example, the slide to unlock idea. It was the first test independent of the ideation phase, and the right animated prototype is this one. It helped me a lot to uncover inconsistencies in the UX and UI design workflow without any programming effort. In Unity, I created several prototypes to explore the possibilities of the MRTK framework and to get closer to my desired solution. And this is also a first test to see how it works. It was a first spoiler menu, but it doesn't has anything to do with the ideation. Then my next experiment was to find a solution for arm tracking. I tried to implement inverse kinematics, but I quickly found out that you don't need to understand what is inverse kinematics, but the important outcome of it was that it was still too laggy and still not accurate enough to track your arm on the right position. So the next solution was to just calibrate your elbow position by your own manually. So I positioned the sphere that you see here on my elbow position, and then activate it, and I have my arm position. This is an inside of first prototype with a lot of interactions. For example, there is a slider with which you can switch between interactions on your arm. I tested also a slider button on your thumb area, but I quickly found out that you should reduce the amount of interaction elements in your arm region a lot. So here in the next version, for example, you see how I reduced everything. And I added also a panel where you can activate and deactivate haptics and audio. Right, and you can move everything around. And at the same time, I designed the layout and icons in Figma. Did several experiments. Also, this is work in progress. And I used the MRTK Figma template and adapted it to my needs, added my icons, and played around with scroll UI examples. And then I switched to HoloLens to try or to figure out if I can use AR directly with my concept. But I quickly figured out, so first of all, it works with haptics. That is good news. But bad news are that the hand tracking field of view is pretty small, smaller than with Oculus Quest. So I can't track my hands when they are close to my body or close to my elbow when I don't look down, and that is not good for my concept. So I switched back to Oculus Quest 2, and now I can show you my final prototype live. One moment. Quests. And should not now like this. Can you see it? Hopefully. again. Okay, now you should see it. First of all, we're gonna calibrate my position, or reset my position. And let's go. Right, and normally I would attach here the, as you see in the camera, hopefully, the split cable. Then I would start to put on the bracelet here, but I want you to listen to the sounds that are triggered, so I plug it out. So what you see now is the last version of the prototype. Here I calibrate my elbow, I position the window, also the settings panel, and I check if it's working. Yeah, it looks good. And here I can set my user ID is 1. Right, you can set if left or right is my dominant hand. If I want to use AR or VR mode, and here you see the iteration. You can activate, deactivate audio and haptics. And when I press here, it shuffles the target device, target object. And right, for example, the pen, or yeah. Here, for example, I have to search for the, is it wrench in English? I don't know. Yeah, and now I can scroll through the list, and the sound that you hear is on one side the audio signal, it's this one, and the haptic sound sounds like this. And when you activate both, yeah, you hear both, and I will just hear the audio on my headphones. Right, now I scroll to the wrench. Hopefully it's the right word. Did I miss it? I missed it. Shit, there it is. Then I touch on my arm. Right, and I can do the same with mid-air. So now I search for the gun. Oh, my headset battery is dying. Right, and that's the prototype, all its functions. And here now you see the VR mode, and this is tilting the window or following my head. Right, but it turned out that the pass-through mode, where you see your real arm and hands, is much better for less cognitive load and yeah, a better feeling of body ownership. Right, that is my prototype. Hope you liked it. And now I'm switching back to the keynote. Right, important to know is that everything what was every button, true or false, is captured as CSV file, so you can open it afterwards in Excel, and you can do this all on your Quest without a PC, and you can access the files via USB or Wi-Fi, and that makes all in all very powerful for evaluation. And right, I did an evaluation with first participants, and they had to go through all possible feedback combinations, e.g. with haptics without, or with audio and without, and this on your arm or in midair. Afterwards, they had to rate their feeling of immersion and the degree of arm fatigue on a scale from 1 to 5. At the end of the test, I conducted a qualitative interview to collect feedback on the overall experiences. The results looks like this for immersion, and the abbreviations are for symbols for example, without haptic and without audio is OB. MH is with haptic. MA is with audio, and MB is with both. And in the last line you see if it's done on arm or mid-air. And the most interesting part is actually this one, where you see the difference from without haptic, without any feedback, just the visual one, compared to the audio feedback. It jumps from 2 to 3.5, and from audio to haptic feedback, so when you have all three modalities, it's just an improvement of immersion from 3.5 to 3.9, so it's not very significantly higher. What was also interesting is that it doesn't make any difference if you do the task on your arm or in midair. It doesn't have any difference on the feeling of immersion. The arm fatigue result was pretty significant, I would say. So if you do the interaction on your arm, it's there's almost no arm fatigue, so it's on 1.8, and in mid-air interfaces the arm fatigue was pretty high on 3.8. Right, and the results are not surprising, as haptic feedback is a subtle support for audiovisual cues. And what was surprising was that some participants even experienced haptic feedback as unnecessary or annoying. And this ambivalent result suggests that haptic feedback was used too much or too often. But regardless of the result, the user study shows that this low budget workflow works with the Oculus Quest. It even works standalone and without a PC, and also with HoloLens 2 or future hardware like Lynx or whatever future hardware comes. It only requires an audio output. This whole workflow creates a new basis for platform independent experimentation with haptic feedback and XR. In my next step, I would like to improve the calibration and the interaction when scrolling. I did an evaluation with 16 probants last month with my mentor Danny Schott, and there it showed again that the calibration and scroll interaction still needs to work more reliable in order to be able to measure and compare task performance. After optimization, we would like to conduct the study again and with more participants. Furthermore, I would like to explore new interaction ideas, such as using 2 fingers to speed up scrolling, and besides that, I also want to apply more best practices for haptic design to improve the immersion. And in addition, in the future, I would like to prototype other use cases, such as navigating through medical data, or for adding multisensory feedback in VR trainings, and or even navigating through playlists, adjusting brightness or volume for basic control interactions where scrolling is needed. And in another experiment, I would also like to try to find a workflow to control the taptic engine from Apple Watch via Oculus Quest. This could be possibly done via iPhone and a WebSocket solution, but still not explored or unexplored. Right, I would like to conclude with a quote from Joshua Blake. This helped me a lot at the beginning not to lose courage to dive into the depths of Unity and C#. Right, and you find all data and PDFs, GIFs, and whatever on Notion. The link is on my presentation. And my most valuable books are these ones that help me a lot to get an understanding how to design 3D user interfaces and how to design things in front of you, objects in front of you. And yes, I hope you liked this video. This was the result of my master thesis, and if you have any questions, you will find me on Twitter or on LinkedIn, and I will update you with any news on these platforms, and yeah, maybe also some new videos in the future. Who knows? So stay tuned and thanks for watching.